In section 3.5, we're going to look at what we call higher order derivatives. And we're going to stick to about the second derivative. So the second derivative is the derivative of the first derivative. So if you can take a derivative once, then you can take a derivative twice. All we're going to do is we're going to find the first derivative, and then we're going to take the derivative of that. Okay, so for example, here we have h of t, and we have our function. And so we're asked to find the first and second derivative of these functions. Something very important, what I'll be looking for on the exam is that you label, so I can tell the difference between the original function and the first and second derivatives. So I'm putting h prime of t, so I'm going to put 1 mark for the first derivative. Then I'm going to use the power rule to take the derivative. So that would be 4t cubed minus 12t squared plus 22t minus 10. So pretty easy there. Now we're going to find the second derivative. So I'm going to put 2 little tick marks there for the second derivative. I will be looking for this on the exam, and I will count off points if I do not see them. Okay, I need to know there's a difference between the original function, the first derivative, and the second derivative. So for the second derivative, I put my 2 marks, and now I'm going to take the derivative of the first derivative. So now I'm going to get, using the power rule, I'm going to get 12t squared minus 24t to the power of 1 there, plus 22. So there's my first derivative and the second derivative. Okay, so if you know how to take a derivative once, all the rules that we use to take a derivative once, we're going to apply them to take the derivative again. So this is what we call the second derivative. Alright, so now we're going to take the derivative of f. So we're going to find the first derivative first. This is the chain rule. We have a group of terms raised to a higher power. So we're going to bring that power down in front of the parentheses. We're going to write the inside function as is, reduce the power by 1, and then I'm going to multiply by the derivative of what's in the parentheses. So that's going to be, of course, the derivative of what's in the parentheses would be 2x, and then plus 3 would be that would be 0, so I'm not going to put plus 0. So just 2x. So we're taking the derivative of what's inside of that. Okay? So that's just the chain rule there. Now I'm going to take the derivative again. Now, here's one thing that's important. Before we take a second derivative, we can simplify the first derivative as much as we please. So to make this a little bit easier, I'm going to rewrite the first derivative. I'm going to simplify a little bit. I'm going to multiply the monomials together, so the one-term factors. So it's 5 times that group raised to that higher power. So I can't do anything with the x squared plus 3 because that's all being raised to an exponent. So I can't touch what's on the inside, but I can multiply together the monomials. So the 2x and the 5, that can give me 10x, and then I'll write what's in the group as is there. So I'm just going to rewrite the first derivative, just to make it look a little bit simpler, so when I go to take the second derivative, it's just a little bit easier. Now, the amount of simplification, the level of simplification is completely up to you, and then really the only reason why I'm simplifying the first derivative is because it'll make it easier to find the second derivative. So notice here that here's my first derivative. I have 1 mark for those. Here's my second derivative, so I'm taking the second derivative now. Okay, so put 2 marks. So for this one, it got a little bit more interesting. So I'm going to take the derivative of 10x times x squared plus 3 to the power of 4. So I'm taking the derivative of that simplified first derivative. Now this requires the use of the product rule. Okay, so here's the first, and here's the second. So all of this. So it's going to be the first as is times the derivative of the second. Now when I go to take the derivative of the second part, since that's a group of terms raised to a higher power, then I have to use the chain rule. Okay, so I'm going to write down here that for this part right here, I'm going to use the chain rule. So it's going to be bring down the power of 4, write the inside function as is, reduce the power by 1, and then once again we're going to multiply by the derivative of what's inside the parentheses. So that's going to be 2x. So it's the first times the derivative of the second, plus the second as is, so that's x squared plus 3 to the power of 4, times the derivative of the first. So I'm taking the derivative of 10x. The derivative of 10x is just 10. Now at this point, we're not going to take a third derivative, so you can leave your answer just like that. So if you wanted to stop here, you could do that. The level of simplification is completely up to you at every step. So if you want to simplify more, then you can do that. So let's say that you stop there, type that into WebAssign, it's going to be correct. On the test, perfectly correct. Let's say that you choose to simplify a little bit more. Let's just see what that would look like. I would take, once again, all the monomials. So I would take everything that's not being raised to a higher power there, everything that's just kind of by itself, a one-term factor, and I would multiply all those together. So I have 10 times 4 times 2. So that's 80. I have x, and I have another x, and multiply those together, I get x squared, and then I have the group x squared plus 3 to the power of 3. Plus, so now I have a different term. So this one, I would just simply put the monomial out front just to make it look a little bit nicer, and then put the group that's raised to the higher power in the back. So this is how I would simplify it, and I'm going to stop right there, because the level of simplification is completely up to you. Alright, so for example 3, once again we're going to take the first derivative and the second derivative. So I'm going to put h prime of w. I'll be looking for that on the exam. And of course this first derivative is going to require the chain rule. I have a group of terms raised to a higher power. So I'm going to bring that power, multiply it times the front of the group. We're going to write that inside function as is. We're going to reduce by 1. Now if I subtract 1, it's like 1 over 1. I have to give it a common denominator, which is to be 2 over 2. So I get 3 over 2 when I subtract 1 from that exponent. Now one thing we don't want to forget is you want to multiply now by the derivative of what's on the inside of those parentheses. So w squared, the derivative of that would be 2w, and the derivative of 2w would just be 2. Alright, so there's our first derivative. Now I'm going to take the derivative again. Okay. Now remember, the level of simplification at every step is completely up to you. I'm going to choose to not simplify and just leave it as is. And I'm going to consider this to be the first. So we're going to use our product rule because we have two things multiplied together here. And I'm going to consider this to be the second part of that function. So remember, the product rule is the first as is times the derivative of the second. So the derivative of the second, so the derivative of that second group, that second part of that product, we have 2w plus 2, well that's just 2. So that's pretty nice and easy. So we have the first times derivative of the second plus the second as is times the derivative of the first. Now when we go to take the derivative of the first, we need to use the chain rule. So I'm going to use the chain rule to find the derivative of the first. So we're going to bring down the power. We have 3 over 2. We're going to multiply that by 5 over 2. So remember, we multiply fractions. It's top times the top, which is 15, and then denominator times denominator. So that's 4. And then we'll write the inside function as is. And then we have to reduce the power by 1. So we have 3 halves minus 1. That's 3 halves minus, keep the same denominator, that would be 2 over 2. So I get 1 half as my exponent. And then once again, we're going to multiply by the derivative of the inside, which is again 2w. And the second term, the derivative of that would be 2. Alright. Now, once again, you can stop right here. 100% correct. Type that into WebAssign. Good to go. If you want to stop there, you can. If you choose to start to simplify, then that's fine too. Let's say that we choose to simplify just a little bit here. Let's say we multiply the monomials together from this first term. 5 halves times 2, that would actually give us just 5. That's really nice. Just multiplying those two together as fractions. Now what's nice here is I can make this look a little bit better. I can say plus, so for my second term here, I'm going to write 15 over 4, says that's my monomial. I only have one monomial here. And then I have a 2w plus 2 times, and then within that product I have another 2w plus 2. So I'm just going to write that as 2w plus 2 squared, and then I'm going to write that 3-term factor raised to the power of 1/2. So this will be the simplified version of what's above. Now you can choose to stop right there and not simplify at all, or you can choose to simplify. The level of simplification is completely up to you. Both of those second derivatives there would be completely correct on the exam. Alright, now for example 4. Make sure that for the test that you know the quotient rule. Okay, the quotient rule will appear on this exam and the next exam several times. Make sure that you know it. Okay, you should know that it is the denominator times the derivative of the numerator minus, now negative is very important, minus the numerator times the derivative of the denominator all over the denominator squared. So make sure that you know the quotient rule. There's no excuse for not knowing the quotient rule at this point. So make sure that you know it. It will be on the exam. If you do not know it, you will lose a lot of points. So we're going to find the first derivative. Okay, so I want to say g prime of t equals. So it's the denominator as is, so that's t minus 1, times the derivative of the numerator. Okay, so what's the derivative of t squared? Well, that's 2t. Minus the numerator as is, which is t squared, times the derivative of the denominator. So what's the derivative of t minus 1? Well, that's pretty nice and easy. It's just 1. All over the denominator as is, but then we're going to square it. Alright, so there is our first derivative. Now, I'm going to simplify here because taking the second derivative is going to be a lot easier if I simplify the first derivative. So I'm going to just simplify a little bit. I'm going to multiply in the 2t, so that gives me 2t squared. Then times a minus 1, it gets minus 2t. And then t squared times 1 is just t squared, so that's minus t squared, all over t minus 1 squared. Okay, now I'm going to combine my like terms. I have t squared and I have minus t squared. So I'm going to go one more time. 2t squared minus 1t squared is just positive 1t squared minus 2t all over t minus 1 squared. Alright, so here's my first derivative, and this is the simplified version, which is really nice because it makes finding the second derivative a whole lot easier. Okay, now once again we have a quotient. So we're using the quotient rule again. Okay, so I'm going to find the second derivative. We put 2 marks there. So it's the denominator times the derivative of the numerator minus the numerator times the derivative of the denominator all over the original denominator squared. You have to know that. Alright, so we're going to start with the denominator. That's t minus 1 squared. Okay, so that's my new denominator. This is what I'm working with now. Times the derivative of the numerator. Okay, so I'm going to multiply that by, well, the derivative of the numerator, t squared, would be 2t. And the derivative of negative 2t would be negative 2. Okay, so minus, now, the numerator as is. I'm going to go ahead and put this in parentheses since there's 2 terms there. So negative out front of the parentheses, and then put my numerator there. And then we're going to multiply by the derivative of the denominator. Now, in order to take the derivative of that denominator, it's a group of terms raised to a higher power, we're going to use the chain rule here. So I'm going to bring out the 2, multiply it times the front, write down what's in the parentheses as is, reduce the power by 1, and then we're going to multiply by the derivative of what's on the inside, which is also pretty easy because the derivative of t minus 1 is just 1. So pretty easy. Now we're going to have to divide that all over the denominator squared. So that's t minus 1 squared, and then we're going to square that again. Alright, now you could stop right there. Perfectly fine and acceptable on the exam. If you choose to try to simplify a little bit more, you can do that. I'm not going to simplify very much here. I'm just going to do a very simple simplification. So I'm going to leave t minus 1 squared as is, and I'm going to leave 2t minus 2 as is, minus, I'm going to go ahead and bring the 2 to the front, so I'm going to say minus 2, then I'm going to write the other groups pretty much just as they are. Not too much simplification here. Not too worried about it. One thing that I really do like to do is when I have something squared and then I square it again, you multiply the exponents. That's the power to a power rule for exponents. So that's really t minus 1 to the power of 4. Okay, so if you're going to simplify, that's perfectly fine. You don't have to simplify. Remember, the level of simplification is completely up to you. On the test, this will be correct, and this would also be correct, and WebAssign will do the same thing. All right, so make sure you need to know the quotient rule. Okay, no excuse for not knowing it on the exam. All right, example 5. We have f of x equals x times x squared plus 3 squared. We will have to use, first of all, we have a factor of x that's being multiplied times this group that's raised to the higher power. Now notice that not everything is being raised to the higher power, just what's in the parentheses there. So the first thing we're going to recognize is that there's a product overall first, and then if we need to use the chain rule, we can do that. So first I'm going to take the first derivative. So the first derivative would be, okay, well, this is the first part of the product, and this is the second factor in that product. And the product rule, remember, is the first times the derivative of the second plus the second as is times the derivative of the first. Okay, so make sure that you know this, no excuse for not knowing it. Okay, very, very important that you know the product rule. Okay, so the first as is, so it's x, times the derivative of the second. Now when we go to take the derivative of what's in the parentheses here, raised to that higher power, we will have to use the chain rule in order to do this. Okay, so we're using the chain rule within that product rule. So we're going to bring the 2 out to the front of the group, reduce the power by 1, and then we're going to multiply by the derivative of the inside, which is 2x. Okay, so we have the first times derivative of the second. We're going to say now plus the second as is times the derivative of the first. And this is actually really nice and easy because the derivative of x is just 1. So that makes things very simple. Let's just make this a little bit more simple. Simplify a little bit because I'm going to take a second derivative. So I'm going to gather all the one-term factors together. So 2x and 2x. So that would be 4. 2 times 2 is 4, and then x times x is x squared. And then I have this group x squared plus 3. And then we have another term plus, and I have x squared plus 3 squared times 1, so I'm just going to leave that as x squared plus 3 squared. Now I'm going to do one little extra trick that's going to make this even simpler for us, extremely simple. Right now if I go to take the derivative, if I leave it as it is, I'll have to use the product rule again. Okay, now that's perfectly fine, not really that big of a deal, but before I actually do the before I actually take that second derivative, I'm going to simplify one more time. This is completely optional, but what I'm going to do to make things really easy for me is I'm going to go ahead and distribute this into the parentheses. Now the only reason why I can do this distribution is because there's not an exponent here. Okay, so that's being raised to the power of 1, so there's no exponent there. If there was an exponent, then I could not distribute. So for example, if I go back up to the very original function, I cannot distribute this x into the parentheses. I cannot do that because it's being raised to that exponent. Okay, if I could have, I would have, but I could not do that. Okay, if there's an exponent on a group, you cannot distribute in. So I'm not going to do that here. But here I can, all right, because there's no exponent. So here I can go ahead and multiply that in. So I get 4 times x to the power of 4, x to the power of 4. So x squared times x squared is x to the power of 4. And then 4x squared times 3, that's 12x squared. All right. Now I'm going to leave this term exactly as is. If you wanted to FOIL that out, you could, but I'm just going to leave that as is. So now when I go to take the derivative again, I have 3 separate terms that are really easy to take a derivative of them again. Okay, so here's my second derivative. I'm putting 2 marks, so f prime prime of x, or f double prime of x. Now I'm just going to use the power rule. This is a very simple term, so power rule here for both of these first two terms. So this is 16 times x to the power of 3. So really simple there. The next term would be power rule. 2 times 12 is 24. Reduce the power by 1, I get 24x. Plus, now this last one is a group of terms raised to a power, so for this last term I have to use the chain rule. Pretty easy though. Bring out the 2, write down the inside as is, reduce the exponent by 1, and then multiply by the derivative of the inside. Alright, I'm just going to stop right there. I'm not going to simplify anymore. If you wanted to simplify, you can. The level of simplification is completely up to you, but I'm going to stop right there. Okay, last straightforward example here. For this example, we want to be careful of something. Anytime that we're taking a derivative and we see a square root, the first thing that we want to do is we want to rewrite the original function before we start. So I'm going to rewrite the original function f of u as a group of terms raised to a power of 1/2. Okay? Make sure that you remember that when you take the square root of something, that's the same thing as raising that, whatever's on the inside here, to the 1/2 power. Okay? Make sure that you know that. Really important for a lot of the problems on the exam. So make sure that you know that. Now, as soon as we do that, now we can actually go and take a first derivative. So f prime of u, so we're going to put 1 mark for our derivative. And this is for sure the chain rule. So we have a group of terms raised to a higher power. We're going to multiply that exponent times the front of the group, write the inside as is, and then we're going to reduce the power by 1. So let's think about this. If I have 1/2 and I subtract 1 from it, we're going to think about that as 1 over 1. I need a common denominator, which is 2. That gives me actually a negative 1/2. Okay, so we're going to subtract 1 from that. Then we're going to multiply by the derivative of the inside. The derivative of the inside, the first term is 8. That's a constant. That's 0. Derivative of 0. Negative 5u, the derivative of that would be negative 5. So the derivative of the inside is negative 5. Alright, so once again, I'm going to simplify this to make this a little bit easier to take the second derivative. I'm going to think about this as negative 5 over 1, and I'm going to multiply this monomial, this fraction, times this fraction. So that gives me negative 5 over 2. Top times the top, bottom times the bottom. Then I'm going to write the group of terms raised to that exponent just as is. Alright. Now I'm going to go and take the second derivative. So I'm going to put 2 marks there. Remember, I'll be looking for that on the exam. And now I'm going to use the chain rule again to take the derivative again. So I'm going to multiply exponent times what's out front, that constant out front. A negative times a negative is a positive. Top times the top is 5. Denominator times denominator, I get 4. We're going to write down the inside as is. Now our exponent is negative 1/2. I'm going to subtract 1 from that again, which means once again I need a common denominator. Negative 1/2 minus 2 over 2, that gives me negative 3 over 2. So I get negative 3/2. And then we're going to multiply by the derivative of the inside, which once again is just negative 5. Alright, now you can stop right there. No need really to simplify any further, but if you wish to simplify further, you can think about this once again as a fraction and multiply the two fractions together. So we get 5 times negative 5 would be negative 25. 4 times 1 is 4, so I get negative 25 over 4, and then I can write the group of terms. Alright, so if you'd like to simplify a little bit more after that, then you can do that.